Good morning, good afternoon, good evening, good night to you all people. My name is Ryan John M. Blaquera, and today we're gonna talk about meiosis. Yes, as you can see, as you can read. Yeah. So basically, what is meiosis? Meiosis is a process where a single cell divides twice to produce four cells containing half of the original amount of genetic information. These cells are sex cells, or sperm cell for male and egg cell for no. Sperm in male, eggs in female. There you go. During meiosis, one cell divides two from four daughter cells. So as you can see here, this is basically the drawing that I made, very wonderful drawing, about meiosis. So this is basically meiosis, and we'll go through on the stages as we move forward. All right, as you can see here, so these are the parts of the meiosis, which as you can see here, the arrow between the first circle is interphase, and what's inside of that is the homologous chromosomes, and the two on top of that is daughter nuclei. So that's going to be the meiosis 1 and 2. And I think I didn't include the other next drawing with that, but because it's too many, it won't fit. But after that, there's a continuation after those two. That would be the nuclei number 2. So moving on to first is, drum roll please. Anytime now. Interphase. Yes, interphase. So what is interphase, or what does it do? Prior to meiosis, all chromosomes are duplicated in a process similar to chromosomes duplication prior to mitosis. So basically, the duplication occurs here. So as you can see here, there's this is where I draw the blue and green dots there. That's going to be the duplication, I think, start. It's going to start. Outside the nucleus of animal cells are two centromes, each containing a pair of centrioles. The two centrosomes are produced by the duplication of a single centrome. During premeiotic interphase, the centromes serve as a microtubule organizing center. Microtubules extend radically from centrosomes forming as aster. So moving on, the next stage is prophase 1. Yes. So what is prophase 1, or what does it do? At the start of prophase 1, the chromosomes have already duplicated. During prophase 1, they coil and become shorter and thicker and visible under the light microscope. So basically, if you want to see the duplication, or basically the centrome, you can use a microscope with that to be able to see it. The duplicated homologous chromosomes pair and crossing over. The physical exchange of chromosomes parts occur. Crossing over, please note, crossing over is the process that can give rise to genetic recombination. At this point, each homologous chromosomes pair is visible as bivalent, a tight grouping of two chromosomes, each consisting of two sister chromatids. So as you can see here, pointing at the two bivalent homologous chromosomes, which is the non-sister chromatids, sister chromatids, and moving on. Anyways, next is metaphase. So metaphase is the central. Wait. All right. So what is metaphase 1, or what does it do? So basically here, as you can see in the drawing, the centroles are at opposite poles of the cell. The pairs of homologous chromosomes now as tightly coiled and condensed as they will be in meiosis. So basically, they coiled now already, differ from the prophase 1. because prophase 1 is the first one, and now metaphase 1 is they're now tightly coiled. So yeah, moving on. Next is anaphase 1. Yep, there we go. Nice one, Ryan. So what does anaphase 1 do? Anaphase 1 begins when the two chromosomes of each bivalent separate and start moving toward opposite poles of the cell as a result of the action of the spindle. So basically, there's a movement here. It's very hard to draw because I'm not a good drawer. Yeah, I accept that. But there's a moving, chromosomes moving here. I think side to side. Notice that in anaphase, one sister chromatids remain attached at their centromes and move together towards the pole. A key difference between mitosis and meiosis is that sister chromatids remain joined after metaphase in meiosis 1, whereas in mitosis, they separate. So take note of that, guys. Chromatids join after metaphase in meiosis 1, whereas in mitosis, they separate. So next is going to be telophase. What does telophase do in the next stage? So basically, the homologous chromosomes pairs complete their migration to the two poles as a result of the action of the spindle. Now, an haploid set of chromosomes is at each pole, which with each chromosomes, sorry for my pronunciation, still having two chromatids. So a nuclear envelope forms around each chromosome set. The spindle disappears, and the cytosinosis follows in animal cell, and cytosinosis involves the formation of a cleavage furrow. So moving on with after that, telophase 1, we're gonna move into the meiosis 1 stage, which is prophase 2. So this is kind of I think similar to the prophase 1, if I'm not mistaken. So prophase 2, what does prophase 2 in this stage? So while the chromosomes duplication took place prior to meiosis 1, no new chromosomes replication occurs before meiosis 2. The centroids duplicate. This occurs by separation of two members of the pair, and then the formation of a daughter centroid perpendicular to the original centroid. The two pairs of centroids separate into two centromes. As you can see in the drawing, they're two separated. The nuclear envelope breaks down and the spindle apparatus forms. All right, nice one, Ryan. Keep it going. Yeah. All right, moving on, which is metaphase 2. All right, so what does metaphase 2 do, or what is it in general, or not in general? So basically, what is it? So in metaphase 2, each of the daughter cells completes the formation of a spindle apparatus. Single chromosomes align in the metaphase plate. Much as chromosomes do in mitosis, this is in contrast to the metaphase 1, in which homologous pairs of chromosomes align on the metaphase plate. For each chromosome, the kinetochores of the sister chromatids face the opposite poles and each attach in the kinetochore microtubule coming from that pole. All right, Ryan, we can move on now. Erase that. Nice one. All right, moving on. Next will be anytime now. Anaphase 2. So anaphase 2, this will be the centromes separate and the two chromatids of each chromosome move to the opposite poles on the spindle. the separate chromatids are now called chromosomes in their own right. So basically here, these two separate. Again, sorry for my drawing. But really, I feel so bad for myself just for my drawing. So anyways, this I'm gonna just interpret, or I'm gonna just tell you guys how the insides work. So basically, this one separates as they move separately with 4 inside, which is the green one. So yeah, moving on to telophase 2. Alright, telophase 2, a nuclear envelope forms around each of set of chromosomes. Cytokinesis takes place, producing 4 daughter cells, each with a haploid set of chromosomes. Because of crossing over, some chromosomes are seen to have recombined segments of the original parental chromosomes. So yeah, my drawing kind of looks like a heart here, but please bear with me because I'm really not a good drawer. So yeah, it looks like a heart or an apple or whatever you want to interpret it, but this is for science, and you know, we have to think like a scientist. So please please interpret this as like the cover, like the, yeah. So as you can see, your 4 haploid daughter. Anyways, yeah, moving on. Yes, please erase that. Thank you very much. So yeah, yep, I think that's all. Thank you guys very much for watching. I hope you have a great day. Drink some water, always stay safe, wash your hands, and yeah, thank you guys. Peace.